Welcome to a lesson with Dr. Powell. We're going to take a look at Pascal's pyramid. All right, now I've engineered this in such a way so that we can use the coordinate system to help us a little bit. Okay, so kind of looking at it from different sides and angles here. We're going to think about, at least in this case, we're going to imagine as we go up for that to be positive z. So like going up this way. And for a minute, let's just let this be positive x and let's see here. Yeah. And yeah, let's let this be positive x and let's let that be positive y coming out that way. Okay, so let's kind of think about the pattern, first of all, of what's happening, and then how that relates to binomial coefficients and how we can get binomial coefficients from this triangle and how this triangle is built. Okay, so let's take a look at that. Okay, so we have coming right here, thinking of this as being, okay, so this is like at the origin, and think of this as being like an x-axis coming along this way. That's the x-axis. Think of the y-axis as coming out that way, okay? So that this is, so this coordinate right here, it has an x value, has an x coordinate of 1. And we're going to kind of follow this basic pattern. How did we get this 1? We got this 1 by going directly down. Now, where there's nothing, we're going to think of that as being a 0. Adding 0, going back this way, 1. And let's see, so we go from here, we go down, and then we go down over and down this way. So down, backwards 1 in x, down, backwards 1 in y. And notice that we have a 0 here, a 0 here, and a 1 here. Added together, 1 plus 0 is 1. Okay, so that's how we get a 1 right here. This is if we assume that in the z-plane, everything is zeros except for this 1 right here. So based upon the z-plane having a 1 at the origin and zeros everywhere else, we actually get these 3 1s appearing here using a similar technique. Down, over, back. So down, got a 1, then a 0, 0, so that makes a 1. This one, you go down 0. And so, okay, well, actually, this is on the, where is this? This is on the y-axis, okay? This goes down to here, a 0 here, but back to 1, right? And then back this way to a 0 over there. So 1, 0, 0 makes that a 1. And everywhere else, so as we hit the plane z equals 1 right here, we're going to get no 1s except for these 3 1s. Let's go up to the next plane, z equals 2, and see what happens. Now, in order to do that, let's kind of rearrange ourselves here. And let's rotate this a little bit. All right, so we can kind of see what's happening here. How did we get this 2 right here? Let's see. Using a similar idea, let's see. We go down, over, and then remember we go back this way because that's like the negative y, so backwards y, backwards x, and then down. So 1, 1, and 0 makes that 2. Okay. Now it becomes more interesting when we hit something in the middle. Let's suppose, see the 6 right here? This 6 happens because 6 down, over, over. So 2 plus 2, so 2 plus 2 plus 2 is 6. See that pattern there? So these 3 2s added together make that 6 right there. This 12, let's see, which 12? Let's look at this 12 right here. See how that 12 is obtained. As we look at that, go straight down and notice there's a 6. And then also notice as we go back this way is a 3, there it's a 3. So 3 plus 6 plus 3 will give us that 12 that's right up above it. Okay, now let's see. How would we get this 30 right here. So that 30 is obtained by going 12, 12, and 6 right there. You see it's always down and then backwards in the x direction, backwards in the y. So kind of in the negative y, in the negative, let's see, on the negative x direction, the negative y direction, yeah, then we are able to add it. So in this way, we get a pyramid of values. This is the way Pascal's pyramid works. Pascal's triangle actually is on the sides. Namely, you see this 2 is obtained by going, so you do it one-dimensionally. So you just throw out a dimension to get Pascal's triangle. So with Pascal's triangle, we go straight down and backwards one in, but if we're ignoring now the y going that way and that way, let's ignore it, then we just don't add that value. So we only have 2 values to add. 1 and 1 is 2. So let's see, how did we get this 3? It's just that 1 and 2. Notice that if we're on the edge, flat, since we're 0 out here, when we go backwards, it's as if we're just doing Pascal's triangle. We're only doing one dimension. So you can see Pascal's triangle occurring on the faces. So right here, let's see. We go drop 4 and 1, so that's 4, right? Because 1 plus 3. 6 is drop 3, 3 right there. So, so that's Pascal's triangle. Okay, now we need to think about multinomial coefficients. How can we get these from this triangle setup? Okay, so let's discuss that. All right, so first of all, if we have, so let's see, multinomial coefficients look something like this. We have a top number. Now, the top number is going to be the z value. So if we're like a z value of 1 here in this plane, so 1, and okay, so 1, choose, and they're going to be looking at things here. Now, as we do this, as we're looking in the plane z equals 1, this guy right here is going to be, let's see, so see, as we look in the plane, okay, so that's the total power. So that's the z total power right there. And as we're looking at this, we think that these 3 numbers have to add together to get 1, which means we're going to have 1s and 0s. So only one of these can be 1 at a time. In order to get that. Now, thinking about this, we're kind of look at coordinates. Let's see, this particular coordinate right here is, so if this is the x-axis coming off this way, that's x, and this is y coming off that way. So this is a 1, 0. So we think 1, 0, and then naturally this is determined by what we put there. So 1, choose 1, 0, 0. So this multinomial coefficient would be 1 right there. This one, likewise, would be thinking would be 1, 0, 1, 0. And what about this one right here? That would be 1, 0, 0, 1. Notice how it's the origin. Well, if this is in the plane z equals 1, it's a coordinate 0, 0 for the x, y, but that would force this guy to be 1 here, since all of these have to add up to be 1. So, but we're kind of positioning ourselves here to get our coordinates by just looking at the first 2 entries, kind of as we think about where we are in position. So we get those multinomial coefficients. All right, so let's take a look maybe at another one. Maybe next line, see this 2, see what would that be? Well, so this is like z equals 2, so it'd be like a 2, choose, and where are we at? It looks like we are at coordinates. So the x coordinate is 1, the y coordinate is 0, so 1, 0, and then a 1. because this has to add up to 2. So this is 2, choose 1, choose 1 and 1. And you could even check this computationally. This is 2 factorial divided by 1 factorial, 0 factorial, 1 factorial, and you end up you really do get 2. Okay, let's do this one over here. Now, see if we're going that way, y-axis, x-axis. This is like a 1, 1 situation here. So this is like 2, 1, 1, 0. So 2, choose 1, 1, 0, which again would be 2 as well, computationally by this formula. All right, let's take a look at another one. What if we go up to the next level? Let's take a look at this 6 right here and see what that is. So in order to see what that is, maybe we should just kind of rotate our drawing a little bit so we can kind of get a feel for what's going on. Okay, so we're doing the 6. So this 6, so we're at level 3, and it says e equals 3, and this 6, because that's 0, 1, 2, 3, and this 6 is at xy coordinates 1, 1. So it looks like we'll have 3, choose 1, 1, 1. So let's see how that would work. So if we write that out, and let's just kind of verify this with the computational formula, 3, choose 1, 1, 1, and that's equal to 3 factorial over 1 factorial, 1 factorial, 1 factorial, and if we compute this out, we really do get 6. Okay, so let's take a look at another one. So looking here, and maybe let's go up a little bit more. Why don't we do something like this 12 right here? So that 12, the x coordinate is 2, the y coordinate of it is 1, and we're at level 4 for the z. So that's going to look like 4, and then the x is 2, the y is 1, so that'll force a z here to be 1 since these add up to 4. So 4, choose 2, 1, 1, and that's going to look like 4 factorial divided by 2 factorial, 1 factorial, 1 factorial, which would end up being 4 times 3 times 2 divided by 2, so just 4 times 3, which is 12, which is exactly what we wanted. All right. Okay, so let's look at another one. Let's look at another one here. What if we bounce up to maybe this 30 right here? Which one is that? So that 30 is on level 5. And if we look at this, you can kind of see, well, if we turn it this way, you can kind of see the coordinates really well. So let's see an x coordinate of 2 and a y coordinate of 2. So that 30, so this particular 30 should be, so it's at z level 5, so that should be 5, choose 2, 2, 1. So that's 5 factorial divided by 2 factorial, 2 factorial, 1 factorial. And let's see, that's 5 times 4 times 3 times 2, all over 2 times 2, which is 5 times 6, which is 30. So we get 30 as expected. So in this way, we could actually label these multinomial coefficients by their placements on the axes, at least in the way that we've drawn it. And we also have discussed the rule of how to build the triangle from one layer to the next. Thanks for watching.